All right, so let's get back to predicting whether our customers are pregnant based on their transactional data. So, a couple of videos ago, we estimated these model coefficients for the independent variables, and we also evaluated how well the model was doing with this F statistic and got its statistical significance, and it showed that our model was statistically significant. We got this R-squared value that I told you, sometimes you'll hear people interpret it as like this means that like we explain 43% of the variation in whether or not someone is pregnant with these specific independent variables over here. So another thing we can actually do is find out what the statistical significance is of each and every individual independent variable. So let's do that next. Okay, so the first thing you need to do is compute the prediction standard error. So I'm going to label that here as prediction standard error, or SE. Sometimes you'll see standard error as SE. And that's simply going to be the square root of the sum of squared errors over the degrees of freedom. So we get 0.38 for that value. Now, the next step of this requires a little bit of matrix algebra. Some of the same types of things you saw when we were talking about the normal equation in the last video. And again, what I'm trying to do here is just to help you build up some intuitions about what's going on behind the scenes whenever somebody's doing a regression. So that way you can interpret the output whenever you use the software. So I'm going to go down here and relabel this sheet linear model. And I'm going to create a blank sheet, and we'll call that model coefficient SE for standard error. And I'm going to make a matrix in there. I'm going to take the labels for all of our independent variables, including the intercept. I'm going to paste that across the top row starting at B1. And this matrix is sometimes called the sum of squares and cross products matrix. And right, we've heard of cross products before, we've heard of sum of squares before, but we're talking about it in a new context here. And I'm actually going to paste those same labels for those independent variables. Excuse me, I'm going to paste special. And I don't know why it's giving me that. I'm going to try Control X. What I'm trying to do is paste this out as a column. So let me try that one more time. Sometimes the paste special feature doesn't give me the same options as it usually does. Here we go. Okay, so I will actually transpose that using the transpose feature here. Click OK. And all right, so now we have, these rows are labeled the same as the columns. So what we want to type in here actually is a matrix formula, but we have to, in order to get this to work right, we have to actually select all of these cells in this entire matrix all at the same time. And then up in our formula bar, we're going to type in equals mmult for matrix multiplication, and then we're going to take the transpose. Remember, and when we looked at the normal equation, I showed you what a transpose was. It was just kind of turning a matrix. So we'll take the transpose of our design matrix. So we'll go here to here, to here. So that would be B8 through U. We'll go all the way down to the 7. So B8 through U1007. Close parentheses, and so we've taken the transpose of that, and we're going to matrix multiply this matrix here. So we're multiplying this matrix here by the transpose of itself. So close parentheses, and then I'm going to press Command Shift Enter to execute that as a matrix operation. And then it gives us all these numbers here, and let me just zoom in so you can see how it's gone through and done a matrix multiplication operation. And we're not going to go over matrix multiplication in this class, but suffice it to say it's really just a combination of addition and subtraction in a systematic way going across the two matrices. So let me zoom back out so we can see what the next step is going to be. We're actually going to take the inverse of this matrix. So that's when you take the matrix and put it to the -1 power. We are not going to, I'm not going to show you how to do the inverse in here. It's actually a really tedious procedure. It's not really complicated, it's just super tedious. And if you want to look that up, if you just sort of go to YouTube and look up how to do matrix multiplication, how to take the inverse of a matrix, you can learn all these things. Not super complicated, but it's just tedious. So we'll do the same thing here. We have to actually select the entire matrix for this to work. So I will select all of this and come out here, and then I will type in equals, and now to take the inverse of a matrix, Excel has a function m inverse. I'm going to open parentheses, and I'm simply going to take the inverse of the matrix we computed up here, and there we go, close parentheses, and then I'm going to Command Shift Enter, and now look, we've got this inverse computed. So this is the inverse of this matrix here. Now to get our actual coefficient standard errors, which we're going to need another, like a row of numbers in order to eventually be able to tell whether each of our model coefficients is statistically significant. That coefficient standard error, we are going to use the index function. So I'll show you how to do that. So the values that we're actually trying to get at, let me zoom in. The values we're actually trying to get at are these diagonal values in the matrix we computed, this inverse of the SSCP matrix above. So the male to male, female to female, home to home, all the way down this diagonal. So what we can do is use the index function for that. But we also need to take the square root of that and multiply it times that prediction standard error that we computed over here in the linear model tab. So over here on X5. So let's go back over to model coefficients. So how are we going to do this? How do we get that diagonal value? So we put in =, index. We can type in the B25 through B44 row. Oh, I put this too far down. So yeah, so we do want that B44. We do want the intercept rather. So B26 through B45. So we take that. Oh, whoops. Let me just remove that plus sign. This will be parentheses. So we take the index of that, and we take this. We put a comma here. And we choose cell B46, or the cell right after, or we'll choose B47 here. But in any case, we need to put a number in there. And we close parentheses and click Enter. And so we don't have a value there. We put 1. That should turn into something. And it didn't work for whatever reason. You see B46, 1. We want the index. There, okay, it worked after I pressed Enter. All right, so this is going to, will that automatically increase? No, 2, 3, maybe now it will. So we want to use these numbers as our indices. So we had 20, including the intercept. And so this is just going to give us those diagonal values. But the thing is I also mentioned just a second ago that we wanted to multiply each of these values or we want to take the square root of each of these values and then multiply it by the prediction standard error. So that's simple enough. We just need to wrap this function here in a set of parentheses, and then before it we will go over to the linear model tab and we will put X5 in there. We will multiply that by SQRT, and that should give us the number that we are after. So for I got 0.04 here. Your numbers are going to be different because you use the evolutionary solver if you followed along on your own computer. And so there we go. Those are the coefficient standard errors. So I'm gonna copy those, and then I'm going to paste them over here. I'm going to paste special and just paste the values, and we will call that row, we will label it coefficient standard error. So I'll put coefficient standard error. Alright, so that's the hard part, and I will show you how to get the significance values for each one in the next video.